In this episode, I'm going to talk about running regression and interpreting the results. In the example data we'll look at, we're going to have reaction time as the dependent variable, and as independent variables, the type of word, word frequency, and the number of orthographic and phonological neighbors. In order to do this, choose linear models from the main menu. If linear models doesn't show up in the main menu, install the GamelJ model first. Then choose General Linear Model and fill in with the variables. Put continuous variables as covariates and categorical variables in the factors box. Choose post-hoc by word type and plot the frequency. Also choose the assumption test by checking residuals histogram and residuals predicted plot. And what we see is that the model accounts for about 3.5% of the variance, and that both word type and frequency are significant predictors. And the number of phonological neighbors is close, so we shouldn't throw it out. Here's the results of the post-hoc analysis of word type. What it does is it compares every value of word type to every other value and analyzes them statistically. So let's look at the results for the number of phonological neighbors. What it tells you is that for every 1 unit increase in the number of phonological neighbors, the reaction time decreases by 1.230 milliseconds. As far as the word frequency is concerned, for every 1 unit increase in word frequency, the reaction time decreases by 38 milliseconds. We can look at the plot of reaction time by frequency, and I put 2 asterisks here, one at 0 and one at 1. That represents a 1 unit increase in frequency, and what you'll see is the difference between the 2 asterisks is 38 milliseconds. As far as the assumption tests are concerned, what we see is that the residuals are skewed. They don't fit in a nice bell curve. They're skewed positively towards higher numbers. When we plot the residuals against the predicted values, we see that the results aren't evenly scattered. They tend to be a little bit bottom heavy. We can convert the reaction times into their natural logarithms in order to handle problems with assumptions. This is a common transformation to do with reaction times. We can do this by choosing Data, then right-clicking under the Reaction Times column heading and selecting Transform. We then select Create New Transformation, and we delete number sign source. And then we double-click ln, which is the natural log, and then choose reaction time by double-clicking on it, and that sets up this new variable here. And then if we click anywhere outside that box, what we get is a new column with the transformed reaction time. Now we can rerun the analysis with a transform variable. So click on Analyses, click on the right-hand window, and substitute reaction time with reaction time transformed, and it will rerun the analysis for you. And if we check the assumptions again, we'll see that the residuals are more normally distributed, and the plot of the residuals against the predicted values is not so bottom heavy. It's more equally distributed. So the results now meet the assumptions, and these new results are what we should report. One important thing is to always include an effect size, and partial ETA square is an effect size. We can interpret it to be numbers around 0.01 have a small effect, around 0.06 have a medium effect, and values around 0.14 have a large effect. So all of the variables in this analysis have very small effect sizes.